Hello and welcome to the Learning Mentor. This is me, Learning Mentor, and in this video series, we will be going to cover design of springs using Solidworks and ANSYS. Now, this is the part 1 of the series, and we will be going to create the part on Solidworks, the spring part on Solidworks. Now, for some information, the bottom left of my screen will have some indications of which key I'm pressing and when I'm pressing. Like I am pressing W now right now, so it comes a W. So please note the keys which I'm pressing because I will use a lot of shortcuts that I will also tell, but you have to also see which key I'm pressing, so you can refer to the bottom left. It will be common through all the series, so hope you get through it. Now, this is the basic definition of a spring. Who don't know, they can refer to this book of Khurmi R.S. Gupta, a textbook of machine design. Now, this book covers the basics of what a spring is and how to design a spring for a mechanical engineer. If the information is insufficient for you, you can refer to a designer's handbook for springs. There are various given handbooks for springs, and without any handbook, we cannot design a spring. So it is better to have a handbook of springs with us so that we can design it. For the simplicity, for here, I am going to use a problem from this book and going to simulate it also in ANSYS to verify the results that will our spring created will support it or not. So this is the problem statement. You can read it. I can also read it, but what we are going to design a spring in SolidWorks. So the solution, if you want to go to the solution, this is an example problem, and you can refer to the solution in the book of R.S. Khurmi and see how the terms come. I have noted the parameters over a page as well, and from here you can note the parameters as well. The wire diameter is 9.49, outer diameter of the spring is 57.94, and the other diameters are like that. Now the main part over here is we can create any spring using the helix tool, but we need a square and grounded ends right now. So here's a mistake in the presentation, but we will have to have squared and grounded ends. I'll attach a picture for you that what a square and grounded end looks like. Square and grounded end. So the rotation will be complete so that the end touches the spring and it is closed, which is important for square and grounded ends, and the end is square. It is in practical life it is grinded to make it flat. The both ends will be flat. So let's go to SolidWorks and design it. Now I am into SolidWorks. I am going to create a new part over here. Now for creating a basic helix, we are going to make a helix right now. So we need to create a circle which will be equal to the inner diameter of the spring, because we want the spring to be, we will use the, you will see what we will do. So we will be using the helix and we will use the outer diameter of the spring. So here I am going to select the circle tool and going to create a circle for the diameter of the spring. This will be equal to the inner diameter. We will be using the inner diameter to create the helix for the spring. So the inner diameter is equal to 37.96 millimeters. By default, my dimensions are set to millimeters. If you don't, you can change from here to mmgs system. Okay, so our base circle has been created. Now we will create a helix curve. Now the height of the helix is 152 millimeters. The length of the spring and the pitch will be equal to 13.8 millimeters. Now I am going to shift some things over here. This will be 180 degrees for the start angle, and let's create an sketch. Now as we see that our helix has been created. Now let's create a profile that would be lofted about it. Now for a helix we need a plane which will be perpendicular to this point over here. So select this point, go to the references, create a plane, and let's select the corresponding plane like right plane and create a plane. So the plane has been created. The plane has been created. Now let's sketch a circle that will be equal to the inner diameter, the wire diameter for the lofting. Now we can see that we can select the point over here. Now let's create a circle some distance from here. Now this circle will be equal to the wire diameter, so let's give it the wire diameter 9.49, which we have calculated earlier, 9.49 millimeters. Since the dimensions are off, the circle has gone very long way. Now let's just drag the circle over to our helix curve. Now what we will do, we will make this point touching the outer periphery of the circle. Now to do that, we need to smart dimension this point and this circle, but we cannot do that because we cannot select the points and make a relation. For that, we will first convert this entity and then make a relation, but converting this entity may result into some problem that this is a flattened out version of the helix. Now this may create some problems, so we are going to refer and make this a construction geometry. Now as this has become a construction geometry, it won't interfere with us. Now to make it perfect, we will make these horizontal in relations and we will add some distance to it. Now the distance will be equal to the radius of the circle, which is 9.49 divided by 2. We have created a tangent arc over here. Now this is exactly pointed over here because the distance from here to here is the radius. Now exiting the sketch. So now we will make a lofted boss base, shift loft base, boss base. Now this we will select helix, and the profile will be, the sketch profile will be sketch 2, and the lofting, where the lofting will be done, will be the helix spiral. Now our spring will be made with not grounded ends, neither squared ends, and this is our spring, basic spring. But the problem over here is that the ends are not grounded, and we won't have an result when we will make it in ANSYS. We won't have the accurate results because of the eccentric loading that we will be creating. Now in order to avoid the eccentric loading, we will make this spring with square ends, square and grounded ends. So now let's make a plane in the top over here so that you can understand how we are going to create it. Now remember, we have chosen 315 degrees. Now we will create a reference plane, check the top plane, and go to references, make a plane, and since the plane is, select the first reference as top plane, and since we know the height of the spring, which is equal to 152 millimeters, put that in, and here is the plane created for you. Now we shall make the planes grounded, the spring grounded. How? Let's select this plane that we have created and create a sketch over here. Now create a circle which will be equal to the mean diameter. Now what's the mean diameter? The mean diameter is 47.45. Okay, the mean diameter has been created. Now let's make some center lines so that we can ground our spring. Now this region we have to create, the region should close the spring, because as this problem statement says, we need the coil to be closed. Now in order to do that, we have to know the angle between these. So since that was 315 degrees, so now add dimension. The angle between this will be, now let's assume that 180 minus 45, since 360 minus 315 is equal to 45, and that 45 is here. Now if you divide the length of the spring with the diameter of the spring, you will have a value of 16.06. I'm minusing 18 from here as well so that we can have a value that will make it equal. Now let's see if the coil will be grounded or not. Will the coil be closed or not? We cannot do this in the spring option if any student asks. Now let's exit the sketch. No, why we cannot do that? Because we have created just a full circle. Let's edit the sketch again. You can do this in one step as well. Now trim the outer boundaries so that this is left. Now we will be sweeping this portion. Now let's go to features and then sweep boss base. Select this profile for the sweeping. Okay, so the sketch profile was selected. Now it has become a perfect circle over here. Now the spring is closed. Now we have to make it square and grounded. Now to do that, we will make a circular rectangle, and then we will just cut extrude it. Let's do it. Let's select this plane and sketch it. Now let's make a rectangle of the length and shall cover the whole spring. Okay, and then let's just cut extrude it through both sides, and we will have our grounded ends. Let's select it and through all both. Then we will have our grounded ends. Okay, now as you can see, we have grounded ends. This is the closest look that we can have. Now we have to do similar thing from the bottom as well. So from the bottom we will be selecting the top plane. So the top plane has been selected. Now we will create a sketch over the top plane. Let's make it normal again. Okay, so now we will create a circle equal to the mean diameter, which is equal to the mean diameter is 47.45. Okay, so we have created the circle. Now we have to create some guided lines and then give it some degrees and let it we need a line over here, so we are going to make a line from here and then to cut over here. Let's remove the lines here. Now let's create the center lines again. I've created the center lines again for the pediment. Now let's smart dimension it the same way we did it earlier. 180 minus 45 minus 18, which is equal to 117 degrees. We will also check for any error that we made. Let's trim the outer circle as well and exit. Now we have to extrude it in and make sure that it doesn't merge for the spring, because in reality we cannot merge materials like these do. Let's go to swept boss base, select the circle and sketch here. Now select the edge over here and the boundary over here. And make sure it is in the direction 2. You can also go for the direction 1, but it will not be completed. Direction 2, and make sure that it doesn't collide. Looks like it's colliding over here, so we may have to decrease some degrees over here in the sketch. Let's edit the sketch. Let's reduce it to 110 degrees. And then again swipe pause space, select the circular profile and the edge, make it direction 2 if it's not working properly. Now see if the is hitting. No, it's not, but it's completed. Then okay, then we will sketch a rectangle over here. Let's go to sketch and let's sketch a rectangular to make square-ended, and features extruded cut through all both, and okay. So we have created our profile. This so this video is completed over here. You can see the spring which we have created with the optimal length and the pitch that were provided in the problem with square-ended ends. So that's all from my side. In the next video we will be covering the simulation part of this. The file part is also provided in the description. The book is provided in the description. Please subscribe to my channel for more videos like these, which will include the conceptual design behind any part and more tutorials like these as well. So make sure you subscribe.